These eerie objects are called quasars. They're some of the brightest and most powerful objects in the universe. They lurk in the depths of space, consuming entire galaxies with their insatiable hunger. Muhahaha. But what are quasars? Where do they come from? And most importantly, are they dangerous to us? Come on, let's find out. Picture a supermassive black hole, a cosmic monster so massive that it can swallow entire stars and bend the fabric of space and time. Usually, there's such a black hole in the center of every galaxy. That includes our own Milky Way galaxy. Ours is named Sagittarius A star. Sounds like the name of a hipster coffee shop, but in reality, it's a terrifying celestial body which is 4 million times heavier than our sun. You could even see it online. For the first time, we took a photo of this black hole in May 2022. But don't worry, even though it's supermassive, it's not going to swallow us up anytime soon. This black hole is relatively small, and it's too tiny to eat an entire galaxy. So it's more like a cosmic vacuum cleaner that sucks up stars or gas that get too close. But there are black holes in the centers of galaxies that are way heavier and more dangerous than ours. They can weigh millions or even billions of times more than our own sun. Now imagine one of these monsters. Usually they're surrounded by a swirling, glowing disk of gas and dust, like water swirling down a drain. It's called an accretion disk, and it's where the magic of quasars happens. As material from the accretion disk falls towards the center, it heats up to millions of degrees, releasing vast amounts of energy in the form of radiation. And this radiation is what we observe as a quasar. So basically, the more material a black hole can consume from its surroundings, the brighter its quasar will be. This is what makes them so bright and powerful, shining like beacons in the night sky. And just imagine, some black holes can actually make entire galaxies their meal. Now, combine their ravenous appetite with some intense radiation, and you'll get a truly awe-inspiring display of cosmic power. No wonder we can see them, even though they're some of the most distant objects in the universe. Quasars were discovered in the late 1950s by accident. Astronomers were just chilling and looking at the sky when suddenly they stumbled upon something strange: radio signals that had no visible source. By 1960, hundreds of these strange objects had been found. Astronomers named them quasars, short for quasi-stellar radio source. These objects were small and far away, but their energy output was immense and difficult to explain. Some thought that these were new types of stars. Others even proposed wild things, like quasars being made of antimatter or being the end of a wormhole. But all these theories were discarded. A scientist named Martin Schmidt was the first one to get to the truth. However, many astronomers didn't believe him. Schmidt had to do a lot of extra work and gather lots of evidence to prove his theory. And finally, he prevailed. That's how we discovered quasars. Don't you love the scientific method? And since then, astronomers have been captivated by these objects. Why? Because they have some pretty eerie qualities. You could call them quasi-quasars. For example, they kind of defy the laws of physics. They emit jets of particles that travel at speeds close to the speed of light. These particles move so fast that they can even distort the very fabric of space and time. But sometimes, they help us confirm the laws of physics. Imagine driving a car. As you drive, objects in the rear window start to appear smaller and smaller until they disappear from view entirely. That's exactly what happens with quasars, except they're moving away from us at incredibly fast speeds, up to 90% the speed of light. Wonder why they're trying so hard to sprint away from us. But in any case, this helps us confirm that the universe does expand for real. Another eerie thing about quasars is that they're incredibly old. Some even date back to the time when galaxies were forming, or to the birth of our universe. Additionally, quasars are some of the most distant objects that we can observe in the universe. Some of them are located billions of light years away from us. This means that when we observe a quasar, we're actually seeing light that was emitted billions of years ago. when the universe was much younger and different than it is today. And that's why they work like cosmic time capsules. Studying them gives us a glimpse into the distant past. You see, galaxies are like giant cities, with stars and planets serving as the inhabitants. But just like cities evolve over time, galaxies also undergo changes as they age, and that's where quasars come in. They are like the urban planners of the universe. They shape the galaxies through their powerful gravitational influence. By eating galaxies and releasing intense radiation, they can trigger star formation and shape the structure of the galaxy itself. It's like the cosmic equivalent of a master chef or a leaf blower. You pick. For example, let's take galaxy mergers. Picture two massive entities coming together, swirling and spinning around each other. As they get closer and closer, their gravitational pull becomes stronger, and they start to merge into a new, bigger galaxy. It's a beautiful and dramatic process, one that can take millions of years to complete. But all this doesn't go without consequences. The gas and dust within the galaxies collide, creating massive shockwaves that trigger the birth of new stars and even supermassive black holes. And this is where quasars come into play. Some quasars may be born during these galactic get-togethers, and thanks to this, they help us study the effects of this process and the evolution of galaxies over time. But it's not all serious science and no fun. For example, how about gravitational lensing? Now, that's something straight out of a sci-fi movie. It happens when the gravity of a massive object, like a quasar, bends the path of light from a more distant object, like a galaxy, behind it. It's like having a really big magnifying glass in space. When you combine a quasar with gravitational lensing, you get some seriously awesome cosmic eye candy. The result is kinda like a funhouse mirror, where objects appear warped and twisted in strange and mesmerizing ways. Oh, so that's what happened to me. Gravitational lensing isn't just for show. It's also a powerful tool for astronomers to study the distribution of dark matter and the structure of the universe. And that's not all. Some scientists have proposed that quasars could help us to build the map of the universe. They can work like giant neon road signs. Turn left at the quasar and you'll reach your destination. They're like lighthouses that help us navigate through space. By analyzing the light from different quasars, astronomers can determine the distances between them and create a 3D map of the universe. And the best part? Quasars are located throughout the entire universe. That's why this cosmic map can give us a comprehensive view of the universe on a scale that was previously unimaginable. Who knew that a giant galaxy eater could be so useful? There is still a lot we don't know about these mysterious objects. In 2007, a team of astronomers made an astonishing discovery: the first true binary quasar. Basically, this means two huge quasars spiraling around each other. What's more, they were hiding in plain sight. For years, scientists had known about this radio source, but had never realized that it actually comes from one lovely couple. The astronomers also estimated that this pair may have a mass of about 100 billion suns. They're super distant though, at an astounding 12 billion light years away from our blue planet. Overall, quasars are a fascinating and complex phenomenon that continues to baffle and intrigue scientists. They may be cosmic galaxy eaters, but they're also playing a critical role in the formation and evolution of the universe. And who knows, maybe one day they'll become one of the keys to unlocking the mysteries of our universe. Oh, you crazy quasars. Do me a favor, will you? Try to imagine the first time you went camping. Maybe you went with your parents. Maybe it happened on a class field trip with your schoolmates. Regardless, try to picture or remember what it felt like as the day was coming to an end. The sun has set, but there's still some light outside. Let's say you were lying down, trying to rest for a bit. What's the first thing you remember seeing when looking up? If you're anything like me, it was probably the overwhelming number of stars twinkling right before you. These stars, most of which you can see without any fancy devices, are part of the Milky Way. Believe it or not, our amazing galaxy is almost as old as the universe itself. Age aside, it's also a pretty nice place to be. The Milky Way is like a cosmic nursery, where new stars are born. And let me tell you, it's home to some of the most fascinating places. at least from what we can see in pictures. Take the Mystic Mountain, an area in the Carina Quasar Nebula. Here things are always splashing and full of energy. That's because of gas columns collapsing and creating crazy opposing jets that are thrown around like acrobats in a circus. It's like a signature move for stars being born, you know? And if you take a look at this awesome picture, you'll see the elements putting on a colorful show. Blue represents oxygen, green is for hydrogen and nitrogen, and red is the sizzling sulfur. Ready for our next stop on our ride through the Milky Way? Check out these huge twisted clouds of interstellar dust and gas hanging out in the center of M16, also known as the Eagle Nebula. We've got ourselves the super cool Pillars of Creation, which are like towering columns where brand new stars like to hide and chill. Now, I know this ain't the first time the Hubble telescopes captured this epic sight, but trust me, this is the most mind-blowingly detailed image yet. The pillars are getting showered with crazy hot ultraviolet light from a bunch of young stars hanging just outside the frame. These stellar superstars are actually causing the towers of dust and gas to gradually get worn away by their gusty winds. Brace yourself for the numbers too. These pillars of creation stretch out for about 4 to 5 light years. Yeah, it sounds big. But in the grand scheme of things, they're kind of like the cute, little siblings of the larger Eagle Nebula, which spans a whopping 70 by 55 light years. The nebula was first spotted back in 1745 by an awesome Swiss astronomer, and it's about 7,000 light years away from our humble abode in the constellation Serpens. Here's the quirky part though. As productive as it might sound, the Milky Way's star-forming activity is quite rare when compared to other galaxies. Astronomers have noticed that the pace at which stars are being born is actually dropping, and they're itching to figure out why. But before we can dive into this weird phenomenon, let's look at how stars come into existence in the first place. It's hard for us to know for sure from down here. What we can gather about a star's life cycle comes from looking at those within our local Milky Way. Stars are formed in colder clouds of gas and dust called nebulae. These areas are pretty common throughout most galaxies. These nebulae have low temperatures that are crucial for hydrogen gas to stick together. As the clump gathers more gas, it causes movement, which itself creates energy. When more gas collides with the already formed clump, all that energy transforms into heat. This keeps going until the temperature grows considerably, sparking the birth of a star. The most secure time of a star's life is also known as its main sequence. I'll spare you the chemistry lesson, but during this time, the star produces both heat and radiation. It's because of the radiation that there's pressure around a star, and it's also the reason for most of the light found in a certain galaxy. Now let's talk star sizes. The bigger the star, the faster it consumes its fuel. These massive stars shine the brightest, emitting high-energy UV lights. On the other hand, lower-mass brighties live longer despite not being as shiny as their larger siblings. There's a variety of star sizes in most galaxies we're able to see from down here. Some stars are 0.1% the size of the Sun, while others have 10 times its mass. Once a star finishes up its fuel, it welcomes its grand finale and transforms into a faded star. Stars about the same size as the Sun or smaller can no longer produce radiation at this stage. Gravity takes over, causing their matter to settle into a white dwarf. For bigger stars, the timeline changes a bit. They too collapse, but there's a lot more stuff burning, and it's also hotter in there. This collapse creates a stronger core. When all of the star's insides are done for, the outer layers collapse in a jiffy. It bounces off the core at nearly the speed of light. It's an impressive explosive event called a supernova. The blown-out material becomes the basis for future stars. It also leaves behind a black hole. Now that we know a bit about a star's life, let's try to look at each generation if you'd like. Stars don't just pop up constantly at the same rate. Currently, the universe is manufacturing only about 1/9 the number of stars compared to its star-forming glory days, which happened roughly 10 billion years ago. One study gave us a peek on the history of star forming. In writing it, 2 scientists teamed up to gather a ton of data about galaxies. They sorted these galaxies based on how far away they were. By doing this, they could track how the brightness of galaxies has changed over the universe's lifetime. Since stars give off most of a galaxy's light, they could use that brightness to figure out how many stars were forming using some fancy math. Their findings confirmed that star formation was pretty wimpy when the universe was young. But as gas started to gather in galaxies, boom! Star formation skyrocketed until about 10-11 billion years ago when it hit its peak. After that, star formation took a nosedive. In today's observable universe, it's dropped a lot. That means around 50% of the stars we see today were born in the first 5 billion years post-Big Bang. A mere quarter formed in the last 6 billion years. So, what's causing this cosmic shift? Well, scientists think it's all about that cold gas that stars need when they're born. When galaxies form, the gas gets concentrated inside, leading to a star formation extravaganza. But then, the gas is used up quickly as stars doze off. When supernovae come into play, they blast away that much needed gas for future star making. Not to mention, it also changes the chemistry of that gas. This crucial piece of information could be a starting point for the star-making decline we see today. Scientists are still not sure why this gas becomes useless. Galaxies are also pretty complex to begin with. There are all sorts of forces involved in maintaining their balance. For instance, when a supernova goes boom, the shock waves can sometimes cause turbulence and clumping of the gas, sparking the birth of new stars. But if the supernova is too wild, it can blast that same gas right out of the galaxy. With no gas left in the area, there's little to no chance a new star could form. Now, what does the future hold? Some scientists can't help but wonder what might happen if no new stars pop up. The universe might be simply filled with black holes and fading stars. Solar systems would become inhospitable as their stars lose power, and those ravenous black holes might munch on whatever material is left. As gloomy as it seems, you do have to admit it is a mind-boggling concept. Luckily, we don't have to worry about it happening anytime soon. The universe is a whopping 13.7 billion years old, but the dark era isn't expected to kick in until somewhere further in the future. But hey, this is just one possible outcome of the decline in star formation. Who knows what other wacky possibilities the universe holds? The Milky Way galaxy where we live looks like a ginormous pinwheel rotating in space. It's a spiral galaxy that appeared around 14 billion years ago. It's filled with a lot of stuff. Stars, nebulae, which are clouds of dust and gas, planets, asteroids, you and me and your parents and that messy kid down the street. You get the idea. And all these fans out from the center of the galaxy in long spiraling arms. A marvelous view. The Milky Way is about 100,000 light years across, and it takes our sun, along with all the solar system, 250 million years to make one revolution around the center of our home galaxy. Wow, that's a big lap. Look at the sky at night, and most stars you'll see there would be located in just one of the Milky Way's arms. Before telescopes were invented, people couldn't see stars clearly. They blurred together into a single white streak, stretching across the sky. It looked like a river of milk. That's how the name of our galaxy appeared. Now let's get down to some recent and very exciting news. an international team of scientists has discovered something they've never seen before, hidden in the center of the Milky Way. It resembles Morse code. Is our galaxy trying to communicate with us? In the early 1980s, astronomers discovered giant, one-dimensional filaments dangling vertically near Sagittarius A. That's our galaxy's central supermassive black hole. And recently, a new kind of such filament has been found, but they're much shorter and lie either horizontally or radially. In other words, they're spreading out like spokes on a wheel, going away from the black hole. Interestingly, even though both types of filaments do have certain similarities, researchers believe they most likely have different origins. The vertical filaments stretch through the galaxy, towering up to 150 light-years high, but the horizontal ones resemble the dashes and dots of Morse code. Scientists were beyond excited when they made this discovery, but they had to do a lot of research to make sure the structures indeed were what they look like. They managed to confirm that the filaments were not random, but tied to the outflow of the black hole. Thanks to them, it became possible to study the spin of the black hole and the orientation of its accretion disk, a rotating disk of matter formed around the black hole under the influence of its immense gravitational force. But let's have a closer look at the filaments we've been talking about. There are around 1,000 vertical ones. They appear in pairs and clusters and are often either equally spaced or side by side like strings of a harp. As for their horizontal counterparts, they seem to be around 6 million years old. Now, both types of filaments are one-dimensional. They can be viewed with radio waves, and they seem to be tied to processes happening in the galactic center. That's it. The similarities end there. The vertical filaments are perpendicular to the galactic plane. The horizontal ones are parallel, but at the same time, they point radially toward the center of the galaxy and the black hole. The vertical filaments are magnetic. The horizontal ones seem to emit thermal radiation. The vertical filaments contain particles moving at speeds very close to the speed of light. The horizontal ones don't do it. There are way more vertical filaments, and they're much larger than those stretching horizontally. 150 light-years against 5 to 10 light-years at most. In any case, the new discovery is still filled with tons of unknown things, and astronomers are ready to start unraveling them. But the filaments aren't the only unexpected and bizarre phenomenon in the solar system. Some time ago, Australian researchers discovered a weird spinning object in the Milky Way, and it was unlike anything they'd seen before. This object released massive bursts of radio energy 3 times every hour, and even though there are other objects that switch on and off, for example pulsars, such frequent pulsation had never been observed before. Some astronomers admitted that this discovery was pretty spooky, since no known object in the sky could do it. Research teams started working on the discovery and found out that the object is likely to be 4,000 light-years away from Earth. It's also super bright and has an incredibly strong magnetic field. And still, if you do all the math, not me, you'll discover that it isn't supposed to have enough power to produce such radio waves every 20 minutes. The theories about the origin of this mysterious object vary. Some experts claim it could be an ultra-long period magnetar, whatever that is. Others think it might be a white dwarf or the remnants of a collapsed star. But it also might be something we've never heard about, an entirely new type of object. But one thing is clear, astronomers managed to observe the signal across a wide range of frequencies, which means that it has a natural origin and it isn't something artificial. Now there's another mystery about the Milky Way. What can I say? It's a mysterious place. Around 15 years ago, astronomers launched the Fermi Gamma Ray Space Telescope. Gamma rays are an incredibly high-energy form of light. That's why when you observe the sky through the Gamma Ray Telescope, rather than with your own eyes, the difference is dramatic. So when astronomers started to use the telescope, they noticed that the center of our galaxy emitted much more gamma radiation than, for example, its outskirts. To put it simply, something is glowing incredibly brightly right in the middle of the Milky Way. But the most perplexing thing is that no one has been able to find a plausible explanation for this phenomenon for almost a decade. Some astronomers suggested that the central region of the Milky Way was glowing with such intensity because the dark matter was getting destroyed there. While no one has ever observed dark matter annihilation, scientists have been hypothesizing about this phenomenon for a long time. Naturally, we wouldn't be able to see dark matter itself, but the process could be producing the radiation the gamma-ray telescope has spotted. That's how it could be happening. If particles of dark matter collided, just like ordinary matter particles do in particle accelerators, they would annihilate one another. As a result, they would burst into a shower of other particles, including the ones that make up gamma rays. But that's where the problem lies. If the mystifying glow was created by the annihilation of dark matter, then gamma-ray particles would get distributed evenly in space. Instead, they gather together in clumps. That's why, to the great disappointment of numerous supporters, the theory based on the dark matter came up short. There is an alternative explanation of why the Milky Way is glowing. The culprit might be a group of millisecond pulsars, which are neutron stars spinning incredibly fast. And when I say fast, I mean about 1,000 times per second. The theory that the glow is caused by millisecond pulsars is quite plausible. As I've mentioned before, the light coming from there is clumpy rather than smooth, and it often happens when the source of light is one individual object, such as a pulsar. Several studies have concluded that due to the nature of the light, millisecond pulsars are the best explanation for this phenomenon. However, many scientists are still not persuaded. Those stubborn folk want proof, right? First of all, they state that the clumps of light may appear due to the interaction of gas between stars and cosmic rays. Besides, the pulsar theory has one more catch. Why would so many of them be clustered together in a perfect sphere around the center of the Milky Way? Ah, space, the final frontier. It's a vast and mysterious expanse that has fascinated us for centuries. But as much as we've learned about it, there are still plenty of things that we've been lied to about when it comes to space. Let's take a look at some of the biggest lies we've been told about this topic. First off, we have the idea that space is just this pristine, untouched wilderness. But that's not exactly true. We've been littering space with our debris for decades. Everything from old satellites to rocket parts. In fact, there are over 20,000 pieces of debris orbiting Earth right now, and they're causing all sorts of problems for future space missions. So if you're planning on visiting space anytime soon, watch where you go. You never know what kind of garbage might be floating around. Did you know that the sun is not actually yellow? It's green. Well, kind of. You see, scientists measure the temperature of a star by the color spectrum it emits. Cooler stars appear red, while the hottest of stars look blue. Our sun emits most of its energy at a wavelength that's close to green, but because it emits other wavelengths too, all these colors mix together, and your eyes see this vibrant mixture as white. From Earth, however, the sun looks yellow because our atmosphere is really good at scattering blue light. If our star was actually yellow, Earth would become a frozen rock, and we'd all be polar bears. Plus, the sun isn't on fire for real. It's a big ball of gas made mostly of hydrogen and helium, and it works more like a gigantic nuclear reactor, constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy, and that's why the sun is so hot. Oh, and speaking of setting things on fire, explosions in space aren't real. Sorry, Star Wars fans. A spaceship can't go down in a violent blast because there is no air out there in space. No air means no oxygen, and no oxygen means no fire. Now, you might also think that there are too many stars in the night sky for you to count, but in fact, you can do that. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the unaided eye. So technically you can count them, but I wouldn't be surprised if you lost count. And if you're worried about flying through an asteroid belt, don't be. Although it does have trillions of space rocks that range in size from space dust to a quarter of the size of the moon, they're very spread out. The asteroid belt between Mars and Jupiter is 140 million miles across, which is 1.5 times the distance between Earth and the Sun. This spreads space rocks thousands of miles apart, making it almost impossible for a spacecraft to collide with one. You'll instantly freeze in space without a suit. Nope. You won't turn into a popsicle right away. It's going to take a bit longer than that, because heat and cold don't really move very quickly in the vacuum of space. But unfortunately for you, there's a bigger problem at hand. You won't be able to breathe. After just 15 seconds, your brain won't be getting enough oxygen from your blood, and you'll pass out. And then, after just 2 minutes, it's curtains for the rest of your organs. So in short, if you find yourself playing astronaut without a spacesuit, it's game over pretty quickly. Did you know that space doesn't have any temperature at all? That's because the temperature is defined by the speed at which particles move and the amount of energy they have. In the true vacuum of space, there are no particles to move around, making it temperatureless. Of course, some parts of space are really hot, like areas around stars. But the further away you get from stars, the more spread out particles are, making those areas of space pretty chilly. Number 9 is our planet's shape. No, it's not flat, but it's not a perfect sphere either. Yeah, it bulges at the equator because of our planet's wild spin. It's like Earth is doing its own little dance. And because of this bulging, launching spaceships from the equator is much easier than from the poles. Now, when it comes to sound in space, it's a bit of a tricky situation. You might think that no one can hear you scream, but that's not entirely accurate. The thing is, sound needs something to travel through, like air or water. In space, things are super spread out. So all those epic space battles and galactic explosions would be completely silent. Yet, there are some places in space with enough particles for sound to travel through. For example, you can hear the black hole at the center of the Perseus galaxy cluster. Another myth is about zero gravity. That's not a thing. There's still some gravity hanging around the International Space Station, about 90% of what we feel on good old Earth. But astronauts get to float around because they're basically free falling around the planet. And let's be real, Hollywood's version of space travel is not the fact. Sure, orbits are a thing, but different altitudes mean different speeds, so moving from one orbit to another isn't exactly a walk in the park. You can't just push yourself in the right direction and hope for the best. You gotta take those orbital velocities into account. This reminded me of the 2013 movie Gravity and how Sandra Bullock tried to survive in space. Hollywood sure added up some fuel to these myths. Yet again, who can blame them? Back in 1976, NASA's Viking 1 spacecraft snapped a photo of a curious rock formation on Mars that looked suspiciously like a face. Some folks out there claimed that it must have been proof of extraterrestrial life on the red planet, but NASA had a different take. According to the space agency, the face was nothing more than a bunch of rocks piled up in such a way that the shadows they cast created an illusion of facial features. It turns out it was just a regular hill that got a little too much credit for being photogenic. The solar system stays in place. Lee. It's zooming through space at a speed of 140 mph, which means that it's whizzing through the cosmos faster than a cheetah chasing its prey. It takes 230 million years for the solar system to complete a full orbit around the Milky Way. It's a good thing it isn't getting a speeding ticket because that would be one astronomical fine. Without the sun, planets would be pretty chilly. We're talking temperatures as low as 455 Rossif Fahrenheit. Brrr. But with the sun around, the planets get to enjoy much more livable temperatures. Of course, not all planets are created equal. Mercury, for example, is the closest to the Sun. Venus, on the other hand, is farther away, but somehow manages to be even hotter than Mercury. The distance from the Sun isn't the only factor that affects a planet's temperature. Other things, like the planet's size and reflectivity, also come into play. So, Mercury being the hottest planet in our solar system is a false proposition. No, just because it's the closest one to the Sun doesn't mean it's the hottest. Even though we've been deceived in some ways, that doesn't make space any less amazing. It's still a vast, beautiful, and utterly fascinating part of our universe, and there's still so much we have yet to discover. Who knows? Maybe one day we will really discover little green people out there, or maybe we'll find something even more incredible. Until then, we'll just have to keep dreaming and exploring. There you got 14 things on our list. Do you have any other space myths to debunk? Hurricane alert! Everyone's hiding. The speed of the wind outside is more than 75 miles. Seems a lot, but this storm is moving at 400 miles. Wait, do such speeds exist? Yes, but to see a storm that fast, you'll have to travel to Jupiter. So, let the journey begin. The planet is huge. Almost 1,300 Earths could fit into this gas giant. It's also incredibly hot, with the temperatures reaching about 43,000 EF at the planet's core. Unfortunately, you can't land on Jupiter's surface because, being a gas giant, it doesn't have any solid surface. But you can go deeper into Jupiter's atmosphere. Look at these thick brown, yellow, red, and white clouds passing by. They are what makes the planet look colorful and kinda striped. If you continue descending toward the center of the planet, you'll see its atmosphere, mostly made up of hydrogen and helium gas, become liquid. It happens because of immense atmospheric pressure. The planet's core itself is a mysterious object. Scientists still haven't figured out whether it's a molten ball of thick liquid or a solid rock 14 to 18 times the mass of Earth. Anyway, exploring Jupiter isn't the main goal of your trip. No, you've arrived here to see the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts are towering more than 5 miles above the tops of the surrounding clouds. The storm is 1.3 times wider than our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot, and it turned out that this monster of a storm goes more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere, and keep in mind that Jupiter's temperatures are 234 EF in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, the highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. There, the heat reached 2,400 F. This temperature is higher than that of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating. But the storm itself is warmer at the bottom than at the top. People have been watching the moving vortex on Jupiter for more than 150 years. Some time ago, astronomers predicted that it would gradually slow down and become smaller or disappear entirely. But that turned out not to be the case. After having analyzed all the data received with the help of the Hubble Space Telescope, researchers were baffled to discover that the winds at the outer boundaries of the storm had actually picked up speed. The change in the wind speed is no more than 1.5 meters per hour during one Earth year. It's a tiny change, but however small the difference is, it still means a lot. The wind speed at the edges of the storm can reach a mind-boggling 400 mph. That's faster than Earth's tornadoes. At the same time, if you found yourself at the center of the Great Red Spot, you wouldn't be too impressed. The winds there move way more slowly. Scientists faced lots of challenges when they were trying to understand the mystery that was the Great Red Spot. It's unclear what fuels the storm. Can it be the nature of the storm's home planet? Since it's a gas giant, Jupiter doesn't have any solid ground, so there's no friction, which might be the only thing that could make the storm weaken. The hot gases in the planet's atmosphere are always moving, rising, falling, swirling, just like on our home planet, where cooler and warmer air mix and merge into one another, forming giant circling storms. Astronomers think that once, several enormous storms could have come together and created the Great Red Spot, and now it keeps going by constantly drawing cool gases from below and hot gases from above. Plus, the storm might be absorbing other, smaller vortices. This makes the Great Red Spot even more powerful. Unfortunately, thick clouds on Jupiter don't allow astronomers to see what's going on in the planet's lower atmosphere. Scientists have been speculating on what may hide beneath the Great Red Spot for decades. Is it a massive volcano? Unlikely. Jupiter is mostly made up of gases, and it doesn't have a crust that could crack, letting lava escape from the planet's interior. There are also a few theories explaining why the storm has its trademark color. It varies from whitish and pale salmon to bright orange and brick red. Some scientists believe the answer lies deep below the Great Red Spot, closer to the planet's surface. A colorless layer of gas might be reacting to the UV radiation coming from the sun. This is probably what gives the storm its red color, but so far it's just a theory. Hey, your guess is as good as mine, huh? Jupiter isn't the only planet that can boast having a giant storm. Another one as wide as our home planet rages on Saturn. It's called the Great White Spot. How clever! The storm has a tail of white clouds encircling the entire planet. It occurs every 30 years or so. This storm indeed starts as a spot, but then it starts stretching and stretching. Astronomers have figured out that the Great White Spot is actually a huge system of thunderstorms. At the top of the storm, lightning can flash more than 10 times per second. But the main mystery about the Great White Spot is where it gets its energy from. Some scientists think it may be powered by the sun. Others argue that the storm's cloud pattern only makes sense if there's an internal source of heat that can power the winds. Anyway, severe storms on different planets of the solar system aren't the only space mystery that makes astronomers scratch their heads. Let's move to Pluto, the largest known dwarf planet in the solar system, and explore its atmosphere. It rises really high above the surface of the planet and has more than 20 layers, all of them freezing cold and extremely condensed. By the way, our moon also has some sort of atmosphere. Called an exosphere, it consists of helium, neon, and argon. It's 10 trillion times less dense than Earth's atmosphere. While traveling through space, watch out for black holes. Whew. A black hole is a place where gravity is so strong that even light can't get out. But black holes can sometimes behave like a massive galactic volcano. From time to time, they flare up. Sounds like me, but instead of spewing lava, they produce enormous amounts of energy. And this phenomenon leaves gaping holes in the surrounding material and gas. A short while ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light years away from Earth. The crater this event left behind could fit 15 Milky Way galaxies. Yeah, I can't my head around that either. During your space voyage, think twice before landing on unknown planets. Otherwise, you may end up in a place like K2 141b. That's a planet outside of our solar system. At first glance, it's not that different from Earth. It has liquid oceans that evaporate, form clouds, condense, and get back to the surface as rain. But instead of water, it rains rocks. The surface of this exoplanet is covered with lava seas dozens of miles deep. The temperatures on K2 141b reach 5,000 AAF during the day. That's toasty enough for the magma in the oceans to vaporize into the atmosphere. Then supersonic winds, which can move at a speed of 1 mile per second, carry this rock vapor to the planet's night side. The vaporized magma cools down, becomes liquid again, and falls as a rocky rain. Not a vacation spot. Too hot. I'll pass. So the idea of panspermia is that life can travel through space naturally. like seeds being spread around the universe. It's been debated for ages, but we didn't have any proof until recently. Now, with new discoveries and research, we're taking it seriously. People used to think it was impossible for living things to survive being launched off one planet, travel through space, and land on another planet, but turns out microorganisms can handle it. Scientists got interested in this again in the 70s when they found rocks from Mars here on Earth that proved it's possible for rocks to travel between planets in our solar system. They figured out some ways that materials can be sent into space and survive the trip. So yeah, panspermia might be a real thing after all. Basically, scientists were wondering if living things could have hitched a ride between planets in our solar system. But for that to happen, microorganisms would need to survive being launched off one planet, flying through space, and then landing on another planet. So scientists have done a bunch of experiments trying to simulate all those crazy conditions. They found that spores can survive each stress individually, and even combined stresses can be simulated in the lab. For instance, microbes could totally survive the trip from Mars to Earth or any other habitable planet in our solar system. And get this, it's not just Mars and Earth that could be swapping germs. There are all these cool moons around Jupiter and Saturn that might be habitable too, like Io, Europa, Ganymede, Callisto, Titan, and Enceladus. Plus, microbes can survive in space for years with just a little UV protection. Like, they could be space superheroes with a dash of sunscreen. And if they're shielded by 2 meters of meteorite, they could live for 25 million years up there. That's longer than most marriages last. But wait, it gets crazier. Scientists found microbes on Earth that were brought back to life after 250 million years. That's like finding a fossil and then it jumps up and says, "Surprise!" All these discoveries have changed the game when it comes to finding life on other planets. We used to think life could only exist on cushy Earth-like planets, but now we know that extreme environments are fair game. And with our improved knowledge of these environments, we've been able to develop astrobiology, which is all about studying the origin, evolution, and distribution of life in the universe. Mars is one of the most promising places to look for life. We've found evidence that it used to have an environment similar to Earth, which means life could have flourished there. And get this, scientists found trace amounts of methane in the Martian atmosphere that could be produced by living organisms. Plus, they recently discovered subsurface liquid water lakes on Mars. So, maybe there are some Martian microbes chilling down there. Europa is another exciting prospect. It has a subsurface ocean that could support life similar to Earth's deep ocean hydrothermal vents or the Antarctic Lake Vostok. And Enceladus has hydrothermal vents on its subsea floor and high-speed jets of water vapor and organic-rich particles gushing out from its southern region. So who knows what kind of alien creatures are lurking out there? Bottom line, space is wild and full of surprises. Who knows what kind of crazy stuff we'll find next? Yeah, that long explanation was all about panspermia. But that's definitely not the only theory about the origins of life in space. There's just panspermia theory, but there's also directed panspermia. This theory is a bit crazy though. It suggests that life on Earth was deliberately seeded by an advanced extraterrestrial civilization. This idea is based on the assumption that life is rare in the universe and that it is unlikely to have originated on its own on Earth. Directed panspermia is basically the idea that dudes from other planets intentionally sent life to Earth. I'm not kidding you. Some people think that extraterrestrial beings might have purposely sent microorganisms, or even whole organisms to our planet to kickstart life here. The idea is that those dudes might have wanted to spread life throughout the universe, and Earth was just one of their stops. It's kind of like intergalactic gardening. They planted the seeds of life and let it grow. Now, This theory might sound a little out there, but some scientists actually take it seriously. They argue that it's possible that life on Earth is too complex to have just randomly formed on its own, and that an outside force had to have played a role. I personally prefer classic panspermia theory over this one. There's another theory called chemical evolution, and it suggests that life on Earth originated from simple organic molecules that formed spontaneously in the early Earth's atmosphere, or in space. These molecules then combined and evolved into more complex structures, eventually leading to the formation of living organisms. The conditions on early Earth were different from what we see today. The atmosphere was mostly composed of gases like methane, ammonia, and carbon dioxide, and there was no oxygen. These conditions were conducive to the formation of organic molecules. One of the most famous experiments that supported the chemical evolution theory was the Miller-Urey experiment in 1952. In this experiment, Stanley Miller and Harold Urey simulated the early Earth's atmosphere in a laboratory and produced amino acids, which are the building blocks of proteins. This experiment demonstrated that organic molecules could be formed from simple inorganic compounds under conditions similar to those found on early Earth. Over time, these simple organic molecules combined and evolved into more complex structures, eventually leading to the formation of living organisms. This process is believed to have taken millions of years and involved many intermediate steps. While chemical evolution is still a theory and there are still many questions to be answered about the origins of life, it provides a plausible explanation for how life could have arisen from non-living matter. Hey, ready for the next theory? Meet hydrothermal vent theory. This one suggests that life on Earth originated near hydrothermal vents on the ocean floor. These vents provide a unique environment where chemicals and minerals mix with hot water, creating conditions that could have supported the formation of organic molecules and the evolution of life. This theory is another idea about how life could have started on Earth. Basically, it suggests that deep under the ocean, there are these hot vents where water heated by the Earth's core comes out. These vents are full of minerals and chemicals that could have provided the perfect conditions for life to begin. Scientists think that the first living organisms could have started around these vents, using the chemicals and minerals to create energy. Over time, these organisms evolved and spread out into other parts of the ocean, the hydrothermal vent. Theory is still being studied and debated, but it's an exciting idea that could help us understand how life began on our planet. The last, but not the least, RNA world hypothesis. This theory suggests that RNA, aka ribonucleic acid, was the first self-replicating molecule that led to the evolution of life on Earth. RNA is capable of both storing genetic information and catalyzing chemical reactions, making it a possible precursor to DNA and proteins. Basically, the name of this hypothesis is a fancy way of saying that life on Earth might have started with a molecule called RNA. RNA is like a cousin to DNA, which is what makes up our genes. Scientists think that RNA might have been the first molecule that could make copies of itself, which is a key part of how life works. The idea is that in the early days of Earth, there were all these chemicals and stuff floating around, and somehow these chemicals combined to make RNA. Then, because RNA could make copies of itself, it started to spread and evolve into more complex forms of life. It's still just a theory, but it's a pretty cool one. And who knows, maybe we'll find out one day that it's how we all got here. Black holes are some of the most enigmatic and sinister phenomena in the universe. They can swallow up entire stars and planets, bending the very fabric of space and time. But what if Earth, our home planet, were to be caught in the grip of a black hole's event horizon? What would we see before the inevitable end? Let's have a look-see, okie dokie. So, a black hole is like the bully on the playground. You avoid them at all costs. It's a region of space where gravity is so strong that nothing, not even light, can escape it. It's like Houdini in reverse. As with snowflakes, every black hole is unique. Each one has its own mass, spin, and charge. And they also come in different sizes, sort of like jeans: petite, slim, regular, and husky, or something. Anyway, there are 4 sizes. The smallest black holes are the stellar mass kind. They're born when a massive star runs out of juice and folds in on itself. They're like the chihuahuas of the black hole world. They may be tiny, but they're feisty. They gobble up nearby matter like a hungry puppy. And even the smallest one is 3 times more massive than our sun. Next up, we have the middle children of this cosmic family, intermediate mass black holes. They're too big to be born out of the collapsed stars. Scientists believe that they may be created when several black holes merge into one. And even though they can't dominate galaxies, at least they can swallow up some nearby stars. Goody for them, huh? But do you know who can dominate a galaxy? The enormous monsters of our universe, supermassive black holes. They're the giants with masses ranging from millions to billions of times that of our sun. And they play a crucial role in the growth and formation of their host galaxies. Finally, there are ultra-massive black holes. Trust me, you can't even imagine the size and the mass of these guys. These cosmic eldritch horrors are extremely rare, but the ones we know can devour entire galaxies like Pac-Man. So, what happens if you get too close to a black hole? Or more like, what would you see in your last moments? Well, first, you reach an event horizon. It's like a point of no return, an invisible boundary that marks the edge of a black hole. And here's where things start to get really weird. For example, time starts to slow down. Not for you, for an outsider watching you from a safe distance. If you were falling into a black hole, you wouldn't feel any different. But if you were watching someone else fall into it, you'd see them slow down and eventually freeze in time, like in a paused video. As you get even closer, you would start to see some pretty mind-bending things. The gravity would cause the light around you to bend and distort, creating a sort of funhouse mirror effect. You might even see a halo of light around the black hole, known as the photon ring, or jets of high-energy particles spewing out from the black hole's poles. You can actually get pretty close to a black hole without feeling any major effects. It's only when you cross the event horizon, then there's no going back. Your goose is cooked. After crossing this boundary, you'd be unable to see anything. For the person watching you from the outside, it would be as if you had suddenly disappeared. Meanwhile, you might start feeling a bit stretched out, like a piece of spaghetti. This is because the gravity is so stark that it's pulling you in different directions at once. There's even a scientific term for it called spaghettification. We'll cover linguinification in another video. Now that you're inside a black hole, you're taking aim at the singularity. It's a point of infinite density in its center, where all matter is crushed down to a single point. It's like trying to fit an elephant into a tiny matchbox. Everything gets squished together until it's as small as it can possibly be, which means it's time to wave goodbye, I guess. And if all that sounds scary, here's another fun fact. Black holes are not rare at all. Actually, there's one in the center of each galaxy, including our own Milky Way. So, does it mean that we'll be eventually sucked into it? And if so, how exactly would it happen? Well, let's see. Imagine a black hole approaching our solar system. At first, it appears as nothing more than a tiny speck in the distance. But as it gets closer and closer, its gravitational pull begins to wreak havoc around. Planets start to veer off course, asteroids are flung into oblivion, and comets are shattered into a million pieces. But just like waiting for the sausage to be served in a German restaurant, the worst is yet to come. Like that joke. Soon, it inevitably reaches the Earth. First, our planet's atmosphere would be pulled towards the black hole, triggering a massive windstorm. and there'd be huge waves on the oceans, the water itself being distorted by gravitational forces. Imagine seeing seas and oceans get stretched out. Earth's magnetic field is generated by the motion of molten iron in the planet's core. But now, the extreme tidal forces of the black hole would disrupt this motion, causing the magnetic field to weaken and distort. All this would cause massive earthquakes and volcanic eruptions. As the planet's crust and mantle were pulled apart, all infrastructure and technology would be completely destroyed. Buildings, bridges, and roads would be torn apart. Okay, let's hit the pause button. Pretty horrifying, isn't it? Nah, but don't worry. You wouldn't even have seen all that, because you would have felt the effects of the black hole much earlier. Back to the future. We'd lose our magnetic field even before everything started to collapse. And this means not only that the weather and climate will become terrible, we'd also be exposed to extreme radiation. These gamma rays and the heat from the black hole could drastically change our planet. Say ta-ta to all our beautiful nature. At least misery loves company. We won't be the only ones affected by a black hole, which is probably even worse. As this beast engulfed the entire solar system, it would consume about everything. One immediate effect would be the disruption of the orbits of asteroids, comets, and all the other bodies. The planets would begin to deform and stretch, their surfaces warping like molten metal. The sun itself would be affected, its surface contorting like a gob of putty. And yeah, all this is scary to even imagine. But now, breathe and relax, because none of this will ever happen. This is the bright side, remember? Your infinitesimal odds of winning the big lottery are even better that the Earth will ever be swept into a black hole. The nearest black hole to our solar system is called Gaia H1. Discovered by scientists in 2022, it's found in our own Milky Way galaxy, about 1,600 light-years away from Earth. Gaia H1 is about 10 times the mass of our Sun, which makes it a stellar mass black hole. It's not very interesting on its own, but its discovery has supplied valuable insights into the behavior of these cosmic monsters. But as you can see, even the closest known black hole is over 1,000 light-years away. They move very slowly, and they'll never get so close to our system to pose some kind of threat. Hey, but didn't you say that there's a black hole in the center of the Milky Way? Doesn't that mean it's going to eventually hoover up our entire galaxy? You may ask. Maybe not in that voice. Well, don't worry. The correct answer is no. The one in the center of our galaxy is called Sagittarius A star. You may remember it from that viral blurry photo that circled around the internet a few years ago. This black hole is indeed very massive and has a strong gravitational pull, like two 8th graders in love. However, it's still a small beam. It only affects objects that are close to it. The objects in the galaxy are all too big and move too fast to be pulled in by black holes. Nevertheless, they're still fascinating objects to study. Scientists are still trying to unlock the mysteries of black holes. And even though they'll never be dangerous to us, they're still a huge reminder of the incredible power of our universe. Now I think I'll turn my attention to the incredible power of chocolate.